Hello, I'm Cheryl McKinney and welcome to Apple's Video Magazine. This is part 2 of Meaningful Math Activities in Pre-K. In part 1, Dr. Sally Moomaw, Assistant Professor in Early Childhood Education at the University of Cincinnati, addressed math standards including the Common Core standards along with the 5 content areas of mathematics. Today, in part 2 of Meaningful Math Activities in Pre-K, Sally will address the importance of number sense. She will explain the progression of quantification for young children and offers some ideas and materials that will help children develop a better understanding of number concepts. As teachers, parents, and caregivers of young children, we need to be aware of the importance of using appropriate materials or manipulatives with our young children to help them develop and understand these important number concepts. Also, Dr. James Olsen, professor from the Department of Mathematics at Western Illinois University, who works in math education, explains some of the brain research in relation to the use of manipulatives. Now let's join Sally Moomaw as she shares information and ideas to help young children develop these important number concepts that are the foundation for future mathematics skills.
Although we have 5 big areas in mathematics that we can explore with young children, when it comes to Common Core standards, we see a very big emphasis on quantification and counting with kindergarten children and now also with preschool children. So I think it's really important for us as teachers to understand how children learn the concepts of quantification. So I want to take a few minutes to talk about that. At the youngest level, say you have 3-year-olds in your classroom that haven't had experience in school before, they typically begin by using what we would call a global way or a perceptual way of quantifying. So let's say I had some little counters here. These happen to be frogs. And I said, hey, Mary, can you get just as many frogs as I have? At this youngest stage, Mary may look at that and say, well, that kind of looks like a lot of frogs. So she may just reach into my bowl and pull a handful out. Sometimes she may actually get the right amount by accident. But in general, what she's looking for is, does that look like it's about the same? And we might be inclined to say, well, that's not math. She just grabbed some. But it is math. Because at this stage of development, it's very perceptual. And so this is how she came up with a good approximation of how many frogs to take. Now, as Mary has more experience and plays with her friends and interacts with her teachers, she's going to begin to realize that to get exactly the same number of frogs or whatever as someone else, she can make a matching relationship. And we call this one-to-one correspondence. So at this point, Mary takes a frog to match this one, and then a frog for that one, and then a frog for this guy, and then a frog for this guy. And that's actually the right answer, and that's a mathematically valid way to solve that problem. Line them up, they're the same. So that stage of one-to-one correspondence appears during preschool and is very important to support because they will be expanding this concept throughout their math career in school. At some point, children begin to realize that the counting words they have learned can be used as markers to quantify a set of materials. So at this point, they may be able to go 1, 2, 3, 4. You have 4 frogs, I need 4 frogs, and then take 1, 2, 3, 4. And that's called the counting stage of quantification. But let me be really clear here. At first, children may just be memorizing counting words. Toddlers memorize counting words. Toddlers are really good at picking up language in most cases, and they hear adults counting with them. They sing counting songs. Adults point to pictures and count, which is all very important. But the toddler may just be remembering the words and not be able to apply them. So when I play a lot of games with young children. I often use a game-based curriculum, and I think this is an excellent way for children to learn to quantify in a very enjoyable environment. So when we play these games, they may draw a card. And that card tells them, this is how many counters I get to take. As soon as the child begins playing this game with me, I'm assessing them. Yeah, I'm playing a game, and they don't know it. But as the teacher, I'm assessing them. So if the child looks at this card, and they see all these dots, and then they just grab some frogs, I know right away that child's at the global stage. The next stage they're going to come to is one-to-one. So when it's my turn, I'm going to model one-to-one. I'm going to say, oh, I get to take one frog for this dot, and one frog for this dot, and one frog for this dot, and one frog for this dot. And then when it's the child's turn, they go ahead and they do it their way. Now, if the child's already doing one-to-one correspondence, point to a dot, take a frog, point to a dot, take a frog, or maybe even setting the frogs on the dots, I know, great, that child's at one-to-one correspondence. So I can model counting. And when it's my turn, I can say, oh, I got this many. Let's see, 1, 2, 3, 4. I got 4 dots. I get 4 frogs. And I can take my 1, 2, 3, 4. Sometimes a child will say, that's cheating, because they don't understand how I could just do that and get my frogs. And then I might say, oh, would you rather have me like set my frogs on here while I count them so we can be sure? And then I can do that while I count them, and they can see the relationship. And it's all about seeing those relationships. And then for children who really understand counting, without me saying, hey, Jerome, count those dots, and that's how you know how many to take, Jerome will automatically do that if he's at the counting stage. So he will just go 1, 2, 3, 4 and take his 4. Now, once children are at the counting stage, there are some really important principles that they need to master that we need to be thinking about as teachers. First of all, do they know the names of the counting words in the right order? Some children may know them up to, say, 4 and then get mixed up. All we do then as teachers is make sure we model the counting words plenty of times. And if we play a lot of games, we can model them many times because we get lots of turns. Another thing we need to watch is a principle called, then this is an application of the one-to-one principle, but one-to-one principle in counting. And we need to watch, do they give one counting word to each object they're counting? One and only word, one counting word. Because we often see children go fast. And they do everything fast, right? And so they count fast. 1, 2, 3, 4. And when they do that, they may miss some. That's very, very typical. We could definitely say that's developmentally appropriate. We expect this in preschool children. If they do this, it doesn't mean they're doing anything wrong for their development. Just like when they say gawk for clock, it doesn't mean they've done anything wrong. They're just operating within their developmental level. And what do we do as teachers? I don't tell them you did that wrong. What I do is put it on myself. When it's my turn, I say, okay, watch me count really carefully, because sometimes I mess up. Make sure I don't miss any dots. Let's see, 1, 2, 3, 4, 5. Did I get them all? Because I don't want to miss any. And so I model making sure I don't miss any. The big concept in preschool math that's identified by Common Core standards is cardinality. Nice, juicy word. What cardinality means is that the individual understands that when you count, the last number word you say means the whole group. So when I go 1, 2, 3, 4, 5, that emphasis on 5 means I have 5 dots, or I have 5 objects, whatever it is I'm counting. And that is really important. I think cardinality is one of the most important math concepts that children need to understand when they leave preschool. And so as a teacher, I want to make sure that I model and reinforce that concept wherever the children are, because they need to be able to apply that in real-world situations. So let's say they're in the block area. I like to hang out in the block area a lot because I can basically teach the whole math curriculum there, and if I'm hanging out there, usually children are going to come over. So I'm in the block area, and Dimitri has come over and gotten the cars out, and he's rolling them around, and he's made a little parking lot, and he's put his cars in there. So I might say, Dimitri, how many cars do you have in your parking lot? And I'm going to see if he understands that question and how he responds. And if he says 4, or 1, 2, 3, 4, then I know that he has applied that cardinality principle to his actual math problem. If he can't answer that question, I'm probably not going to say, well, go ahead and count them, because when I've done this with children that don't understand cardinality, this is what I usually get. They count them, 1, 2, 3, 4, and I say, so how many do you have? And they look at me like, what I am going to do is, oh, well, can I come over and see your cars? Because I want to be a valet too, and I want to park some cars. So let me see how many you've got so far. Let's see, you've got 1, 2, 3, 4. So you've got 4 cars, right? So let me go see if I can find some more cars, and we'll see if we can put them into your parking lot. And so I'll roll one over and say, let's see how many we have now. 1, 2, 3, 4, 5. Oh, now you have 5. And that may be it for right now. And then later, when Dimitri's over in the manipulative area, and he's pulled out some Duplos, and he's making a tower, because he's been to Chicago, and he saw the really tall buildings. And so he's putting his Legos on there, and I'm like, I want to make one too. Can I make one? Let me see. I wonder how many blocks you put on your tower. 1, 2, 3, 4, 5, 6. You put 6? Okay, let me see if I can find 6 that look like yours. 1, 2, 3, 4, 5, 6. And let's put them together and make sure they're the same height. Okay, now we can keep on building. So wherever he goes, I'm just going to very casually model cardinality until it really becomes part of him. He understands what it is, and I see him begin to apply it on his own when he's asked a question like that. The everyday experiences are very, very important. That's how they learned language, isn't it? But beyond that, I also am going to introduce an interactive curriculum that really focuses on quantification. And that's why I like a game-based curriculum. So one of the things I might do is just put out a die and some really interesting counters. If it's, let's say it's in the autumn, I might have some really interesting plastic pumpkins, and we can roll the die and see how many pumpkins we get. Sometimes it's more fun if you have a place to put the pumpkins. So I might have like an ice cube tray for each person, and we see who can be the first to fill up the ice cube tray. So we roll the die, and that's how many pumpkins we get to take. And then I can ask even more mathy questions, like how many more do I need to fill this row on my ice cube tray? Or if I get one pumpkin this time I roll the die, will that fill up my row? And these are all math questions. They're real important math questions. But to the child, we're just playing a game. So naturally, we're talking about the game. At another time, I might put out some little games that the child could play. So this would be a very, very simple path game. Each child has his or her own path, and the teacher if he or she is playing. And we have a mover. So back to the frog. I only have frogs to play with today. And so now when I roll the die, that's how many spaces I have to move. Now, folks, this is a little harder. So here I go. I rolled a 3, 1, 2, 3, and here I sit. Now I roll a 2 on my next turn. If I go 1, 2, that really doesn't look like 2 to a child. A lot of them will go back to the beginning and start over and move 2 because that looks like 2. But eventually they get the idea that when we play this kind of game, we move forward. And you know why this is really important? This is giving them the idea of a number line and the fact that we can move forward along a number line. There have been several studies that have demonstrated the importance of this type of game with Head Start children, with preschool children. And the researchers speculate it's because it does essentially model a number line. And this is what they need to be developing inside their brains. So this is another type of material that I think is important to consider as part of the overall math curriculum. And when children get very good at that, we can move them to a little bit harder games, like a longer path, where they all maybe play on the same path. This is not a very exciting game board. It was actually one designed for a research study. But you get the idea. There are lily pads, the frogs hop along it, and this is basically an extended number line.
The progression that we've kind of all learned in our teaching methods class is physical manipulatives first, and then pictorial representations, followed by the symbolic. Actually, last semester I was doing quite a bit of stuff with brain-based research and brain-based learning. And on the one hand, you might think of using manipulatives, oh well, that's more for the hands-on learner, the kinesthetic learner, or the visual learner. But it turns out that using manipulatives is going to help all students because everybody processes things visually, and the visual representation kind of trumps anything else. Okay, it's how we're hardwired, whether it was for survival or finding food or something like that. The visual is just very important. So I think it's a misnomer to think that, oh well, this student is really bright and they can do it symbolically, they don't need manipulatives. I think giving all the students manipulatives is going to help them understand it in new ways, and we know from brain-based research that the more connections there are in the mind to an idea, the better they understand it and the better they're going to be able to use that idea later on.
I think it's really important for teachers to understand that these kind of interactive games that we can play with children have been shown in research to be very important to children's learning, and there are some important reasons why. And this is as opposed to, say, we went and bought some workbooks at the drugstore, or maybe we ordered some that were given to us to use in the classroom. There's a big difference between children working with real materials that they can move around and things that are stuck on a page in a workbook. And let me show you why. If children are playing with actual objects like the frogs, not only can they play a game where they draw a card and take some frogs and get a different math problem over and over in a fun way that's motivating, but also they can construct other relationships. So let's say a child has gotten a set of 4 frogs. I might say, how many do you have? Oh, 4. What if this yellow guy takes a little hop and goes over here? How many are left on this side? And how many are over here? Is that still 4? The child probably doesn't know that. So we can figure that out. Well, we can figure it out. 1, 2, 3, 4. We still have 4 frogs. Oh my goodness, that's interesting. What if a friend comes and joins him? So now we've got 1, 2, 1, 2. Is that still 4? Let's see. 1, 2, 3, 4. So they can begin to model decomposing a set of objects, which is what we do when we add and subtract. And we can start asking questions along those lines. If we have 4 and 2 run away, how many do you have left? If you have 2 and 2 friends come, then how many do you have? And so they're hearing the math that's related to arithmetic operations. They should be hearing this in preschool. They can't get that out of a workbook page that shows you a picture of 3 frogs and then says write the numeral. A lot of the children won't be able to write the numeral anyway. And we have a lot of research that shows that even if we put a little dotted line and show them how to write it, that doesn't mean they understand how to apply that to a real math problem, not until much later. So what is appropriate is to use materials that they can move around and put in lots of mathematical relationships. When we limit children to looking at just pictures and then counting and maybe sticking a numeral with them, we are really limiting their conceptual development in mathematics. I'm not saying it's not good to read counting books with children, but what I am saying is it's really important to have a rich environment where we integrate the language of math with actually playing with real materials that we can move around. But as teachers, it's absolutely imperative that we understand why this curriculum is needed. And we have to be able to explain that to principals, to administrators, and to parents. One thing that seems to be very helpful is to make math games similar to the rather boring one I showed you earlier that link to books that children love. So if children love the book Corduroy about the little teddy bear, then I can make a bingo type, or I call them grid games, with teddy bears. I can even buy the corduroy stamp at the bookstore and put corduroy on my little grid board, and maybe they can get a teddy bear counter to give to each corduroy, so corduroy has a friend, or a button, because in one of the books corduroy loses his button. So the object could be to find a button for each one of the corduroys on the game board. Or I could make a path game where you try to take a button to corduroy whose image is at the end of the path. We have found that when we link math games to stories or books that children really love, they play the math games a lot more, and they also read the books a lot more. And so the curriculum basically is self-reinforcing. We get more reading done, we get more math games, math playing done. I often might think about specifically incorporating math into dramatic play. So we have a grocery store. Well, it's a lot more fun if we've got some prices on the groceries and some money and some cash registers, because then we can really act out going to the grocery store and buying things. I try to keep the prices within small enough numbers that children can conceive of them. So I wouldn't charge more than maybe 4 cents for each item, or I could even say $4 for each item, but 4 units. Often on my price tags, I like to actually put a visual representation. So if they're going to have pennies to pay for their items, I might have 4 pennies drawn on a card, so that children at the one-to-one correspondence stage could actually match pennies and go shopping. We want everybody to be able to play. Or if I have a restaurant in dramatic play, we can put a menu out that has items they can order and that has the prices on there, and then whoever's taking the order may have to actually add up how much the person owes so they can pay. We haven't gotten into tipping yet, percentages. That might be for later elementary school. But we can at least have the prices so that they can pay the bill. We can introduce the same kind of thing in the block area. If the children have been building garages, we might have to charge to get your car out of the garage. So we could have some money over there for them to use also. So math can be integrated into all of these areas, but it needs to be done consciously by the teacher, and then the teacher needs to let everyone who's going to work with the children understand that also, so that whoever is in that area can implement math. The math language that we use with children is highly critical. We know, again, from research that many children struggle when they go into more formal education, as in kindergarten, first, second, third grade, because they don't understand the language. It's not that they can't do the math, they don't understand what the teacher means when she says, if you had 2 and got 3 more, how many is that? So if we start to use those terms while they're young, it just becomes part of their brain development, part of their language development, and they can respond so much more easily than when they get in these more formal situations.
We hope this 2-part series on meaningful math activities in pre-K has given you ideas and information to help develop math skills for young children. Thank you to Dr. Sally Moomaw and Dr. James Olsen for sharing their ideas and information and materials that can be used to incorporate math in these early years. Remember that you are a young child's first math teacher, so let's make good use of this valuable time. Thank you for joining us.